This is the final video for the overview of the school index, which we're going to cover the summative growth component. What we'll notice about the summative growth component is it carries the largest weight. The preset weight is 34% of the overall index, but in a typical elementary or middle school, it will likely climb closer to 43%, since those schools will not have a graduation rate and often do not have enough English learners for the English learner progress or participation. So in this example, we are going to look at a new type of measure that's been used in both the parent dashboard and in the school index called an adequate growth percentile. Let's begin by reviewing some of the different growth measures from the CCSO and their practitioner's guide to growth models. Before, maybe a quote from Dr. George Box would be appropriate that says essentially all models are wrong because they are giving a probability, not a certainty, but some of these models are useful. So let's take a look at some of the models that you might be familiar with. A residual gain model is used in Delaware and with the Reading Now network. Student growth percentiles were originated in Colorado for educator evaluations and have been used in Michigan. What Michigan did was they combined the student growth percentile with a benchmark to say, was that growth percentile adequate for you to reach or maintain proficiency? This is called an adequate growth percentile, which is used in the school index, which we'll cover in detail in this video. Also, a multivariate model is used commonly in New York and North Carolina and Tennessee. Some more simple models, like a simple gain score, can be used with the PSAT 8-9 and PSAT 10 and SAT because they're on a vertical scale. So we can simply subtract what the previous score was for what the new score was, even though it may be a different test because it is on a vertical scale. And you're probably familiar with categorical growth, which means we move from not proficient to proficient. So we move from one category to another. These used to be called performance level changes in Michigan. And this is one of those alternatives for writing SLOs for educator evaluations, and usually we'll use a simple gain score or a categorical growth model. Those that are found in red need a much larger population and are usually done with school accountability. For the M step, what we have most common is student growth percentiles. This doesn't utilize demographic information. This only uses previous test data. So take, for example, this whole group of students that scored around a 220 on the third grade test, and then when they took the fourth grade test, they varied from about 250 to about 335, and they scored in these different ranges. And if we isolate on this student here who scored a 310, we would say that, well, they scored better than 75% of the students who had a previous score as what they did in third grade. So now in fourth grade, they scored higher than 75% of students, and they scored lower than 25% of students. So we say they have a student growth percentile at the 75th percentile. Likewise, we can look at another group of students that started at a much higher rate. They started with a 280 score instead of a 220. But they also score in a range, except their range is a bit higher, from about 285 to about 350. But again, there's a student that scored at exactly 310. But in this group, that 310, even though it's the same achievement score, has a different percentile rank. Because in this case, over half of the students actually scored better than a 310. So this student is at a 42nd percentile in terms of its student growth percentile. So student growth percentiles are a relative ranking based on your previous test score. So you need to understand this concept that these two students that both scored at a 310 can have two different percentile ranks because of their previous testing score. So this will help you to understand when we look at the data, how we come up with an adequate growth percentile. So in the same place that you downloaded the school index Microsoft Excel tool, you also had the opportunity to download a summative student data file. And in that summative student data file, you will see the grade for students, their performance level in terms of not proficient, partially proficient, proficient, or advanced, their scale score, the standard error, the z-score, the student growth percentile. And what I want you to notice is that these student growth percentiles can range from 1 all the way to 99, or in this case we have an example down to 13 and up to 95. What you'll normally see is students who score low are going to have a lower scale score and they're going to be not proficient. In fourth grade, 1400 is the cutoff for proficiency, so these 5 students are all within a point of being proficient. This student at a 1450 is advanced and is 50 points above the proficiency. Now what you'll notice in general when you look at your student data file is that the students that scored very high can still have quite a range of student growth percentiles. This particular student scored better than 63% of other students compared to his 3rd grade test. Now what an adequate growth does is it says if they would have scored in the bottom 8% of the state, they still would have been on track to maintain proficiency because they're such a high achieving student. So since they didn't need to score very high because high achieving students tend to continue to score extremely high, it's saying that their target for their SGP was at the 8th percentile. This student scored in the 63rd percentile, which is certainly higher than the 8th percentile, so we would say yes, they met the adequate growth percentile. If we look at a low performing student, what we'll notice is their target is much higher. They had to score in the 85th percentile in terms of their student growth to be on track to become proficient because they were so far from proficiency. They were 50 points below proficient. They only scored better than 21% of the rest of the state, which was not what they needed to show adequate growth. They needed to score at the 85th percentile in the state, so they did not meet the target. Here's a group of 5 students who are all very close to proficiency, between a 1399 and a 1400. And you'll notice some of them had a very low SGP, others of them had a very high SGP. But their targets vary based on how well they achieved in the past. So here's a student who probably scored quite a bit higher in the past because the target was only 40%. But you'll notice that the SGP was the 13th percentile, so they did not meet the target. Either did the student who scored a little better than average at the 54th percentile because the target was the 55th percentile, so they did not meet the target. The students who scored at the 90th percentile, the 61st percentile, and the 95th percentile all had larger values than their adequate growth targets, so they each met the target. So for all of your students in grades 4 through 8, they either met the target, yes, or they did not meet the target, no. And this is how you get a percentage of students who met the adequate growth percentile. The state average is around 50 to 55%, depending on ELA or math. So directly from the Michigan Department of Education, they explain those growth targets or the adequate growth percentile as how much growth a student needs to consistently attain to be on a path to reach or maintain proficiency within a set time frame. Basically, if you're not proficient, did you grow enough that you're going to be proficient soon? And if you are proficient, did you score well enough, not drop far enough, or maintain your score, or grew a little bit so that you would maintain proficiency? I wanted to show you some unique things in your student file. So here's my actual student file and students who did not make adequate growth and students who did make adequate growth. And these are all my fourth graders. This is my student growth percentile for ELA. And I want to show you that you'll see scores that range from 1 to 99. You'll also see targets that range from 8 to 91. So some very rigorous targets there in the 80s and 90s. But for the higher achieving students, some very low targets in the single digits or in the teens. So we see a fairly solid distribution across 4th, 5th, 6th, 7th, and 8th grade. I did notice some abnormal behavior at the high school level that I can't really explain, but I will point out to you. Because in 11th grade on the SAT, they are still assigned a student growth percentile that ranges from 1 to 99. So we get this normal distribution, this not a normal distribution, it's actually a flat distribution, but we get expected values for student growth percentiles at the 11th grade. But what we do not get is we don't get this wide range of adequate growth targets. We tend to get only a handful of them, and some of them very high at the 97th and the 75th percentile. It acts the same way, and it's the same methodology that they're using for 11th grade as 4th through 8th grade, but I just have a little more trouble explaining why there's not an expected distribution of adequate growth percentiles. I do think in 11th grade that they set the AGP to you have to be proficient within 1 year. They're not really specific on this, but they are saying that they set all the adequate growth percentiles so that people would maintain or gain proficiency within 1 to 3 years. And I do believe that in 11th grade they set it to 1 year because they only have 1 year left of school. So 3 years was the maximum, and that was based on the limitation of M-STEP data that we only have 3 years of M-STEP data. Now just to point out to you a little bit the differences from what you're probably used to on my school data and what you're seeing in the school index. My school data is going to report the student growth percentiles, and we'd expect, based on the state average, to have about a 50.0 or 49.9 mean student growth percentile. I'm showing the state here where about 40% would be in that average from 30 to 70 percentile. About 30% would be below average, 30 percentile and below, and about 30% would be above average, about 70% and above. I'm showing you here Ottawa Area ISD, where I have access to actually the student data, to show you a few numbers and how they change. So Ottawa scores a little bit better. They have about 41% that are average growth and 33 that are above average growth. Their mean SGP is 53 versus the state, which is 49.9. However, if I only look at full academic year students from 4th through 8th grade, so this does not look at 11th grade because there's a little bit of concern with doing an SGP from middle school all the way to 11th grade. So if I just look at 4th through 8th grade and full academic year students, that mean actually goes up to 54%, which might be what you expected because they were with the school all year. When you use the school accountability data, and for that data I actually made sure that the students were with the district for 2 years, and how well did they meet the adequate growth percentile, it actually jumps from 54 percentile as a normative SGP to more of a criterion measure on whether they met the AGP or not, and it jumps up to 63.2%. So in your school index, when you click on the tab for summative growth, here is our sample K-8 school. And basically, we have this target in ELA that 58% of the kids will make adequate growth, and in math, about 51% will make adequate growth. So we look at all of our students and we say, well, what percent made adequate growth? And it happens to be 44% made adequate growth. The target was 58%, so they didn't meet the target. So we say how much of the target did they meet? So they had 44% have adequate growth. The target was 58, so they met about 76% of the target. In ELA, in math, it was about 34% met the target, but the target was 51%, so we say 68% met the target. So when we average math and ELA, we get 71% of students met the target for adequate growth. It does tend to show subgroups less than 30 but greater than 10, so we can see the 21, but it's not calculated. We can see the 24, but it's not calculated. The 80 is calculated, and it's calculated in the same way, except it's a little higher score of 77. And then we equal weight these, and we take the average of 71 and 77 to get 74 for the summative growth index value. That 74 is lifted back up to the overall index, and here is that same 74. It has the largest weight of the 4 components, so it has the largest factor to go into the weighted index that we add all these up to get our school level index overall of 78. So that is an overview of the summative growth measure on the school index and how the state is using an adequate growth measure to determine whether or not which students or how many students made adequate growth that they might reach proficiency or maintain proficiency based on their student growth percentile. Hope this was helpful.